Hey everyone, welcome to TSP Weekly. This is your tech startup podcast for Thursday, June 26, 2014. Today, once again, we're recording at the Center for Entrepreneurship at the Dune campus of Conestoga College. My name is Darren Conley. I'm a local tech entrepreneur here in Kitchener-Waterloo. And with me, as always, is my co-host, fellow tech entrepreneur, Stephen Campbell. How are you today, Stephen?
I'm well, thank you, Darren, and I have good news for you. I'm here to help you with your confusion.
Okay.
Are you confused?
I am now.
Thank you.
I wasn't before.
So I have a question. I think I need your help with it, or maybe I can help you with it.
All right.
Would you accelerate your incubator, or would you incubate your accelerator?
Oh, dear. I don't know if I want to get myself tangled up in this terminology mess that you seem to be laying out for us.
So I always was curious, so I took it upon myself to use this as an opportunity to educate myself.
All right.
So accelerators are usually for-profit, usually venture capital investors. They're looking to generate a return from their equity-based investment, as opposed to an incubator, which is typically not for-profit. Usually a university, college, or some sort of an economic development corporation. And they offer the same things. They'll provide a range of services from financial support to business advice or office and development space. But the incubators are not for profit and the accelerators are for profit.
Excellent. You know, that's wonderful to know. I feel like I've been put through kind of day one of Startups 101.
You can go to sleep tonight. Soundly.
Perfect. Well, having got that out of the way, maybe I'll take this opportunity then to introduce our guest. Our guest for this week's podcast is Andrew Finkle with Structured Printing. Now, do I say structured or Structur3D? Do people ask you this a lot?
It's a good question. The people who do ask, I appreciate. First off, I want to say thank you for having me on today.
Yeah, our
this
pleasure.
is exciting. I look forward to our chat.
Sure.
It's structured. The 3 is supposed to be an E backwards.
It's clever. I don't want to I don't want to confuse it in the speaking of it, but it looks great on paper.
No problem. Yeah. So that's one of the things early on we were a little bit nervous about going out with it because of the amount of people that didn't get it. But we spoke with our marketing mentor, and he kind of assured us that when we move kind of into a more broader customer base, they're going to see this as a little bit of a treat. Like they're enlightened to what we're doing and actually kind of build some value. So
sure.
Hopefully our nerdy, geeky user base will appreciate it.
No, it's good. So we can feel like we have a bit of an insight. We're in on the joke.
Exactly, yeah.
Quote unquote, right?
Yeah, I like it. It's really cool.
Excellent. Well, we're going to talk to Andrew a little bit later, just as far as getting his story and hearing a little bit more about what structured printing is all about. But for now, we want to dive into some tech news here. Got a few things to look at tonight. First of all, big news, had a visit by the Prime Minister of Canada. I'm assuming most of the people listening to the podcast are Canadian. If you're listening to this in the United States and you don't know what a Prime Minister is, he's kind of like the President of Canada in a way. Less power.
So how did it go? Did you give him some meatloaf, or what did...
Oh, I didn't see him. I actually heard about it. I was driving home from this very building, and I heard about it on the radio that he had been at Communitech earlier that day. So I didn't get a chance to hear, but I think, Andrew, you guys work out of that space, right?
Yeah, so we were given a heads up early in the week, maybe Monday or Tuesday, that a very special person from the federal government would be visiting us on Friday.
They didn't actually tell you it was the Prime Minister?
I wonder who it was.
Okay.
Thursday night, late at night, they said, oh, by the way, it's going to be the Prime Minister. We're going to be bringing in the bomb-sniffing dogs in the morning. We're not going to be letting anybody else in who isn't a resident of the Communitech hub.
Wow.
But we were actually selected, Structured Printing was selected as one of the few handfuls of hardware companies that were able to showcase to PM Harper.
Wow. So you had a booth of some sort, or he just kind of came around to your workspace?
So we were given... one of us was allowed to go, so I didn't attend. Charles, the American of the company, went. He's working on getting his citizenship, so maybe that helps get him in the good books.
Sure.
There's hope for him yet.
So we were in this email, we were given the heads up. We were told we would get a 30-second slot for one of us to pitch.
Okay.
We would have a table and we were actually located in the I forget the name of the hall of the hub where they have like BlackBerry, Google, the long showcase area there.
Yeah.
And we actually moved there for the morning, set up our demonstration, and he came by and chatted with us for about 30 seconds.
Wow.
But
wow.
It was exciting.
Sure. And did you hear like what was his reaction? Did he seem to like what you guys are doing? It was kind of like smile and shake a hand.
He was really impressed.
Okay.
No, we were able to actually like get the pitch in as far as I know, and there was awesome pictures that got published by Communitech of him spending an extra amount of time, it appeared, at our booth.
Sure.
But he was really impressed by the flexible materials we were doing and the foods. He was
Sure.
playing with the icing sugar. And
did you print his profile in Nutella or anything? Or?
We should have. That would have been good.
I guess if you had a little more notice, you could have set something like that up, right?
Yeah. If our product had a little bit of, if we could print oil too, it would have been great.
Sure.
It would have impressed him as well.
Yeah, absolutely. Very
I did
cool.
see the picture that Communitech put up, and your logo was on his T-shirt. I guess you had it in the background. He was wearing a T-shirt with the logo on it or something like that.
I think
just
Charles
your
was
logo?
there
Oh,
wearing
okay.
the T-shirt right beside him.
Yeah, that's what it
we
was.
were able to get some good
So I was like,
shots.
"Ooh, that's sneaky."
Yeah.
Now,
I like
now
that.
it said here, like the purpose of his visit was to promote this federal government program to give out $100 million over 5 years to 15 different companies across Canada. The article that I read, and we'll post a link to it on the website for the podcast, but it said that Communitech was going to be receiving some of these funds. Like, do you know? Was it startups based out of Communitech that are kind of vying to get a piece of these funds that are being offered, or is it Communitech itself, or do you know how that works?
So, from what I believe and just what I've read, it's for second stage companies, with the example they gave being ClearPath Robotics.
Right, and ClearPath already has 50 employees. They've been around for 5 years
and they've raised
now.
a Series A, and
We mentioned them on our last podcast. For those who have been following along with us, they have that Twitter-controlled robot that they had put together for their 5th anniversary. But anyway, so
that's cool.
So you guys aren't quite at the stage that
no. So we're pretty early.
be.
So I believe, based on the numbers and kind of the wording that I've come across, that second stage kind of meaning around Series B. So people looking to raise in the $5 to $10 million range.
Right.
And if you look at the numbers, 100 million over 15 companies, that kind of works out to those numbers.
Yep.
Where we are right now, Structured Printing is a part of Communitech HyperDrive seed accelerator.
Right.
So good thing we got that clarification earlier. So we did accept a little bit of seed funding, so that's before a Series A, from Communitech HyperDrive in exchange for a small amount of equity,
Right.
and some world-class mentorship and space and things like that.
Yeah. Don't give away your whole story. 'Cause we want to get into it a little deeper later. No, it's all good. Very cool. I've never had the experience of the Prime Minister visiting my hometown or a place down the street. I literally live down the street from Communitech pretty much, and part of me was thinking, oh man, I wish I could have been there. But I guess if it was like high security and residents only, there wouldn't have been a chance for me to get in there anyway.
It was a bit tricky. I actually avoided the building in the morning and did a little bit of work on at the University of Waterloo.
Sure.
I was able to meet Paul Martin as a kid, which was also very exciting.
Oh, okay.
He stayed at the Ramada Inn where I was working as a high school job.
Oh,
pretty
okay.
cool.
Did you carry his bags or something?
I got to hold the door for him and shake his hand. And at the end of the weekend, he left a nice check with the label Liberal Party for like a nice tip, which was pretty cool.
I was just about to ask, was he a good tipper? But Paul Martin, was he not the finance guy? This is showing how little I know about Canadian politics. I feel horribly unpatriotic right now.
Honestly, I was young. That's my excuse.
You have a good excuse. I on the other hand, do not, but okay.
So we were just recently in Ottawa, my wife and I. My brother lives there, so my wife is an American, and we drove by the Prime Minister's house, I guess.
Sure.
And you could have hit it with a baseball.
Right.
There was one police car there, and she was just astounded at how just laid back everything was. There was a small fence, but boy, you couldn't get near the equivalent in the U.S.
Yeah, I think
so it was
there's
neat.
yeah. I've actually never been to Washington D.C., but as I understand it, the president's residence is a little more difficult to hit with a baseball.
Yes,
Yeah.
and there were more than one police car out front.
Sure,
So,
sure.
yeah, it was cute.
Well, let's move on here. Just looking at, there's a couple articles that appeared in our local news, tech section of our local news, talking about robots, not necessarily local robots. We've got one story out of Germany and one out of Japan. So in Germany, apparently they've made this robot. It's a valet robot. You pull up your car, and this is in an airport parking lot. Pull up your car, you drop it off in this particular area, and this robot, which looks like some sort of high-tech forklift.
Like a Stingray.
Yeah, it's called Ray. At least it has Ray printed on the side of it. It picks up your car, carries it off to wherever it's going to be parked as you're traveling, and I assume retrieves it for you when it's time for you to drive back home. They charge kind of a per day rate for using this car. The name of the article, it says Uncanny Valet. I think it's a little play on words with the Uncanny Valley for those who have done any reading in the world of robotics. The Uncanny Valley refers to how close you can get to a human representation without quite arriving exactly there. And speaking of that, another article here out of Japan about a robot that actually looks eerily human, to quote the article here. It's a robot that is in the Japanese National Museum of Emerging Science and Innovation. It's a bit of a tour guide robot, although I don't think it moves. It kind of sits and talks to the museum patrons. But it's being hailed as a very near representation of human interaction with these robots. So once again, kind of raises this question of the Uncanny Valley. Things kind of get creepier and creepier as you approach human likeness until you actually create something that's indistinguishable from a human, which we haven't arrived at yet, I think.
Or have we?
Not that we know of. One of you could be robots and I wouldn't even know it, huh? Or it could be a robot. So, Andrew, I know that your background is in engineering. I don't know if you dealt with robotics very much in your past.
So my background is in chemical engineering and nanotechnology. So we were... I learned a lot of electrical engineering, but the limitation of my actually getting into 3D printing was because I had this itch for getting into robotics.
Interesting.
And I wanted to learn more, and through the programs I took, I didn't get enough experience. So by building the 3D printer, I learned about microcontrolling and things like that. So
sure. And no chance you would mistake a 3D printer for a person.
No, but what's interesting is the open source movement behind the 3D printer I built is called RepRap, and the goal of it is for it to kind of self-replicate itself.
Right.
Cloning, yeah. So eventually this could be part of this Uncanny Valley idea.
I wonder. So let me ask you guys, just as a matter of opinion, would you feel comfortable interacting with a human-like robot? Like, is this something that kind of weirds you out, or is this something where you think, yes, we must press on with the development of this technology. We must make robots indistinguishable from humanity. What do you think? Stephen?
I don't know that you'll ever succeed in making them indistinguishable, but they're everywhere, and I think you're gonna want to keep pushing that envelope forward. I think it's a huge problem for Google, the parking robot in Germany, Ray, because once they get their self-driving cars up and running, they're all going to want to go park themselves all the time. So it'll be a big problem. They'll be getting big bills from the parking lot in Germany as they all shuttle over there and just park themselves. It's almost like a Disneyland. It'll be a ride. All the Google cars will be lined up.
Yes, to ride the Ray.
Yeah, to ride the Ray, or to date Ray, or I don't know.
It would probably make Ray obsolete pretty quickly if you have self-parking robots or self-parking cars. Then you don't need a robot.
I think there's going to be a transition from one to the other, though, right? So
sure. I
think there'll still be some value in Ray for a little while.
This is like Ray is like the incremental step from self-driving cars. We'll have quote unquote self parking
Yeah.
through Ray, and we already have self parallel parking cars, right?
Ray's kind of the upgrade pack to make your car self-driving, right?
Sure. And then when Google comes out with the full self-driving package, then we'll do away with all the incremental options on the way, right?
The closer and closer the Google car gets to being human, the more need it'll have for entertainment.
Sure.
So it'll want to go on its own ride somewhere. So that'd be cool.
Oh,
There's another
Steven.
business model spin-off.
There you go. And robot entertainment for other
Sure,
robots.
look at all the pet stuff that's the whole industry for pets, right? Sweaters and little boots and all kinds of stuff and
there you
food. And
Yep.
so if you have your own robot car,
Yep.
then, oils and different, window tints. I don't know what.
Oh, dear.
Well, and growing up, my
Oils.
sister had a pet robot, a Neopet.
Right.
So I could see this evolving into, feed your car, maintain, doing your regular oil checks will get you points and
Sure.
make the car feel better. Yeah, gamify the
Absolutely. Thank you,
the
Andrew.
maintenance of the car.
Yeah, that's right. Eh? Now, would you want, getting back to kind of the human-like robots, would you want like a human-like robot, in your home, washing your dishes or walking your dog or, doing what thing? I'm assuming like at some point when we have robots in the home, that we already have like the Roomba, right, doing our vacuuming for us. But do you want something that looks like a person and that invites kind of human-like interaction, or would you prefer having a robot in your home like the Roomba that is very much a robot and there's no mistaking it for, for anything that has a personality?
Other than maybe a scale that you would step on to get your weight.
Does
No,
it
that's
have-
the Roomba.
Does it have a personality? Oh, you might mistake it for a scale.
Right, yeah.
Oh, I see.
Other
Sure.
than that, it's
I
just
thought
a
you were
circle
saying
on
you
the
want your
ground.
scale to have personality, like, "Hey, fatso,
Yeah.
why don't
Hey,
you
great
lay
job
off on
today,
Why
my-"
don't
buddy.
you, go for a little walk or something?
That's right. Yeah, I don't know. What do you think?
So I personally welcome our robot overlords. I think I would be receptive and not think it's a weird situation, but maybe I'm the weirdo here. I have no problem with these day-to-day tasks being
Sure.
completed by someone who appears and interacts with no distinguishable differences from a real human being.
I wonder if it would be good for lonely people. And I'm not joking here. I mean, like for people who generally don't get out very much and have a hard time with making actual human contact, like maybe if you had a robot that's human enough to even if you knew it wasn't real, to fool your brain into feeling like you've had a little bit of socialization.
Well, didn't Tom Hanks chat with a volleyball in the Crash
Yeah.
movie for months?
See, there you go.
And
but then
there's the recent one where he's talking to an
Yes.
operating system.
Her, that's right. Have you
Yep.
seen that movie?
I haven't seen it yet.
And I know, Steven, have you
on
seen
my-
it?
Very
You haven't
disappointed in it.
You didn't like it?
No, I couldn't get over it as a bit of a tech guy when he programmed her. It was just too cheesy, and I was willing to suspend my disbelief, but it would just turn me off, and I couldn't get into it after that.
I thought it was really cool. But I mean, you have to, if you start partway through, a lot of the cool stuff I liked was the stuff as the movie developed. And I won't give away any spoilers.
Okay.
Right.
But there's the way the story progresses, I think, is very interesting, is all I'll say. But
Yeah, it lost me. I rolled over and had my cranky face on, I think. And, I don't think I saw the rest of it.
So I think it'll take more to impress him with this Uncanny Valley realistic robot.
I think so.
Could.
I think so.
I think a lot of the advantage is how dynamic we are. You add the thumb to us and we can do a whole lot of different stuff, right? So maybe
Right.
the closer the robot gets to being able to help your son finish a Nintendo level,
Right.
And then get up and cut the onions so I don't have to cry, and then take out the garbage.
Right.
So the Roomba can't do all those things because it's just a circle on wheels.
it's
So
optimized
Yeah.
for that one task.
right. So if you're getting more dynamic and able to do more things, that's kind of why we've been able to do the thumb theory.
Sure. And
so-
something that I would, I don't know how listeners are going to judge me for saying this, but I have a 4-month-old at home who often feels like she can't settle down or fall asleep unless you kind of hold her and bounce her and walk around with her for 10 or 15 or 20 minutes sometimes. And I have thought to myself several times in the last month or two, wouldn't it be nice if I had a robot that could bounce my child a little bit for me and help her to fall asleep? But it would have to be something, she likes the warmth. She likes being
that
held
human
close to a
touch.
body, so it would have to be very human-like, right?
Sure.
But then I'm like, what am I thinking as a father? I shouldn't be saying I want to pass my 4-month-old off to a robot to be cared for. But I'm sure the parents out there will sympathize with me. There are times, as much as you absolutely adore your children, that you just want them to fall asleep, and I actually developed a bit of tennis elbow or something from carrying and bouncing her so much, right? It was straining my joints. So anyway, parents out there, if there are any parents listening to this podcast, please let me know if you sympathize with me or you're judging me as a terrible dad. Either way, I welcome your feedback.
And if you invent that robot, Darren would like 20% equity in the idea, since
yes, this is my standard standard
disclaimer.
pitch. Any ideas that you develop as a result of hearing our podcast, 20% equity has to come to me. Sorry, guys, that's just the rule. All right, let's move on from robots. Getting a little more closer to Andrew's area of expertise here. Another article that came out recently about a jewelry store in Toronto, or I guess a jewelry company, not a store quite yet. The name of the company is Joseph Nogucci.
I think I like Nogucci.
I think it's Nogucci. Which, ironically enough, is not the name of either one of the founders.
Yeah, it's a collective.
Mario Christian and Luca Daniel Lavorato, there's my Italian pronunciation for you, are the two founders of this. But the company is doing 3D printing of jewelry based on architecture, and they're saying it's wearable architecture. So they have a range of products from $69 all the way up to $1,400, and they're using 3D printing technology to create jewelry based on their own backgrounds in architecture. So one of them has a Master's of Architecture from the University of Toronto, as well as degrees in art and biochemistry, whereas the other one has a degree from University of Waterloo here in town. In material sciences and structural engineering. So somehow that diverse range of backgrounds has combined to them doing jewelry and architecture together in the 3D printing world. I think this is really interesting. I'm sure I've heard of there was another group outside of Canada, I think in Europe, that was doing 3D printing of jewelry where they could make like exact replicas of the Eiffel Tower or other kind of major monuments that you could wear on a necklace and things like this, and it's down to meticulous level of detail, since it's actually all done with the perfect digital measurements, right, to create these things. Andrew, I know this is your area that you're dealing with in your own structured printing is a little bit different, but still in the same kind of realm here. So most of the time when I hear about 3D printing, I'm hearing about either like prototyping or I'm hearing a lot about jewelry. So are there a lot of people making jewelry with the 3D
jewelry printing? Is one of the I'm going to say low-hanging fruit, but not in a bad way. It's just one of the simple products that you can directly print and sell, which has a lot of value because you're just you can customize each one. It can be a one-off. You can tune the design for the size of someone's wrist or things like this. So it looks like in this example here, they're directly printing. It could be a stretchy bracelet that has this intricate internal design.
Sure.
And that's the ad of jewelry, right? Is you want it to look really pretty, really aesthetic,
right.
With really complex or something that is not typically seen to kind of show off. So these are things that 3D printing naturally can do. You could have these really complex geometries that could not be made using like an injection technique or things like that.
Right, that's what I was going to say. Something that couldn't be made by traditional jewelry manufacturing techniques in the past, right?
And one other huge application of 3D printing in jewelry making right now, and also dentistry and a few other similar industries, is lost cast molding. So you can print this really intricate earring design that you designed in your own CAD software, all in your own home, 3D print it, and then actually create the mold, which you can cast pewter and different metals in, and mass produce at several hundred units of this product. So using 3D printing to get that first mold is actually a huge application right now as well.
Sure. Now, how about this? This is something that just came to me as we were talking here. Once again, 20% equity, guys, if anybody comes up with this idea or runs with this idea. But what about the idea of making like backups, for lack of a better term, of your jewelry that you currently own, right? So for instance, I have a very unique ring that I purchased 10 years ago for my wedding ring or an engagement ring or something like this, and I'm concerned that if it gets lost, I'll never be able to find something similar to that again.
Yeah.
So somehow I get I can get a digital 3D scan of an existing piece of jewelry, so that if I ever do lose it, then I can get a replica 3D printed, right?
Almost for insurance purposes, or for valuation, or for proof,
or just to minimize the loss, right? The worry.
Yeah. So
about
I'm gonna jump in here and throw some validation to your idea.
Sure.
A company called Shapeways, which is an online 3D printing service, just added gold today.
Oh.
So 18 karat gold, rose gold, white gold, you can have 3D printed. So if
Interesting.
you had lost your wedding ring on a Friday and went, oh, shoot, you can
we'll
upload
bleep it out, don't worry.
If you had your 3D design already scanned for your wedding ring, you could upload it that Friday afternoon. It would be printed over the weekend and shipped to you Monday morning.
Wow.
And you would have an exact replica of your wedding ring within a week.
Wow. So you don't even have to tell your wife that you lost it, potentially.
Exactly.
Honey, I have absolutely not lost my ring. Don't worry.
I didn't want to blatantly say that.
No, of course.
The thing I really see is it's such a huge industry. I see so many people wanting to just make their own jewelry. Like if you could sit there and design your own wedding rings.
Exactly.
So for how close is this whole 3D printing technology to being affordable, like a PlayStation and a couple $100 investment into my house?
So right now, I would say the printers that are kind of designed for the at-home market, kind of call them desktop 3D printers,
right,
range in the order of a couple $100 up to a couple $1,000. Right now, I think for the trade-off of ease of use versus quality, somewhere around $1,000 is the range right now, but it's dropping really quickly. There was actually just a 3D printer on Kickstarter called the Micro 3D, which was selling for $199.
Right.
Wow.
They're shipping in the new year, so I guess, or later of this year, just before Christmas, I believe. So the price is around, for $500, you can get a decent printer if you're willing to put in a little bit more time to learn.
The price would affect the materials that can be printed, the level of resolution of the printing.
So to be honest,
speed,
a lot of those parameters are very consistent because the main factor controlling that is the motors, which are more or less universal across a lot of the 3D printers.
Okay.
One of the trade-offs you kind of take for going with the cheaper printers is you're using some more open software, so there might be a little bit more glitches, a little bit more things that could go wrong along the way, less documentation, so you kind of have to solve the problems yourself, which can get frustrating.
Sure.
Whereas if you go with the safe $1,500, $2,000 MakerBot, they've got a 1-800 number you can call, and they'll help you out. So it's not necessarily the quality of the print, but I would say the reproducibility and reliability is the factor that comes into play.
Sure. I noticed, I don't know if either of you guys have been to the Kitchener Public Library at their central location since they just renovated it within the last few months, but they have a MakerBot set up there in the library that, as far as I know, you can go in with your whatever your 3D design is, and get something 3D printed there in the library. Now, I'm assuming they don't do it for free. I haven't asked them about pricing, but I didn't see any signs with pricing posted. So if you can do it for free, then there could be some nice opportunities.
So that's something
for
I've been really intrigued in. They actually the library sent a tweet to us at Structured Printing. Saying, hey, we've got a 3D printer, so we're going to look into some collaboration with them. But For a young kid right now that's interested in 3D printing, if you can go down and
just play with it.
For a little while.
Which is every kid.
Every kid,
It's such a cool thing, you know.
It's so cool. I'm still a big kid playing with my 3D printer.
Yeah, Darren's grown up, but I'm not. I'm still a kid too.
I don't know if I call myself that grown up.
So I want to go explore this and see. Exactly.
So what else do we need? So I get this printer. Then do I need a specific software?
So
let's, before we get into nitty gritty, as far as that, we'll transition away from talking about the articles here, and I want to talk a little bit about your own background and stuff, Andrew.
Sure.
But before we even get into that, we've already been talking about 3D printing for a little while on the podcast here. But one of the things that we came across, Stephen and I, when we were kind of doing some research before doing the podcast, and yes, we do some research, folks. I know it sounds so spontaneous, but we try to read a few things before we record. One of the things the research showed was that there's still a huge lack of awareness among the average consumer, the public, about what 3D printing is. I think people have heard the term, but we've seen businesses saying they're spending half of their time just educating their potential customer base about what 3D printing is and what they can do, and then the other half is everything else for the business. So maybe just to clarify exactly what 3D printing is. So if in the future, if anybody out there is wondering what it is, they can just get referred to this podcast and they'll completely find out. If somebody came up to you and said, "What's this 3D printing stuff I hear about so much?"
Okay,
what would you say?
To give the comprehensive answer here, 3D printing is an additive manufacturing technique. So as opposed to something like CNC that's subtractive, we're adding essentially atoms together to build up a big physical product.
Okay.
Excuse me. The common 3D printing that's been getting a lot of hype recently is called fused deposition modeling. So this is what your MakerBots or your RepRaps or all of these at-home 3D printers use, this fused deposition modeling or FDM 3D printing. Okay. So how that works is let's go back to a typical at-home inkjet printer right now. So it works on two different axes. Yeah. So you can print a two-dimensional image of something that you see on your computer. Sure. So how 3D printing works is it takes those two motors that control your two axes and it adds a third. So now you can move upwards. So you have
X, Y, Z.
Y, and Z axes now.
Or XYZ for you American listeners. Yes.
So imagine you take a 3D CAD file or computer automated designed file, which you could download. There's a website called Thingiverse, which offers thousands of free 3D designs that you can take. You can augment them yourself, customize them, or you can start from scratch and build your own in something like AutoCAD, 123D Catch, Google SketchUp. There's a lot of good open source free software to do this. Sure. So you take this 3D file now, and you have to turn it into a whole bunch of small 2D files. Okay. So what you do is you take this 3D CAD file and put it into a slicer program, and it will, depending on what type of resolutions you've chose, slice it up into a whole bunch of two-dimensional cross sections of your 3D print. Okay. Or of your desired final object.
And these are like layers that in the printing process will be printed individually?
Yeah, exactly. So you could imagine something like a bust of a human. It will start out kind of like an oval shape. It will move inwards kind of like a circle around the neck and then kind of taper back out. Sure. So each one of those will be one of the 2D files that will be added up in this 3D printer. Okay.
So it's not like you're taking a block of wood and carving something out of it. No. You're taking material and like
putting it in together, adding it up.
Kind of pixel by pixel, so to speak, right? And does it deal with creation kind of on that level? Is it a pixel? Is talking about pixels like the right way to conceive of this, or?
I would say I haven't heard of the word pixel, but I've been listening to the audiobook Makers. which is by Chris Anderson from Wired Magazine, and it's really good. And he kind of compares it to atoms are the new bits. So instead of throwing bits together kind of on a computer and sharing bits, you're sharing these physical atoms.
Okay. So depending on the resolution, if it's a very fine resolution.
So resolution is the term that's kind of used. So
Sure. Yes.
FDM typically has this resolution around 100 microns or 0.1 millimeters.
Okay. So that's the smallest.
Yeah, and you could imagine
could do.
something like the photolithography technologies that are used to make computer chips. You can actually 3D print with that with resolutions on the order of tens of nanometers, hundreds of nanometers.
Wow.
So there is you can go quite low.
Sure.
But you could imagine that because each layer needs to be printed, the smaller the layer, the more layers there are, the longer it's going to take. So these are the
Right.
trade-offs you have to imagine while you're printing.
Right.
So
So for a typical, non-engineer, non-startup person out
Yep.
there who's thinking to himself, do I need a
the hell is
3D
this guy
printer?
talking
Like,
about?
why would I need a device like this? I can understand if I buy a 2D printer, I can print documents, I can print a letter, I can, print off directions to somewhere. But why would I want to purchase a 3D printer? What kind of things might I want to make? I guess we've talked about jewelry already.
Sure.
I've heard in the news about printing your own guns. Hopefully people aren't doing a whole lot of that.
So that was one of the things I was going to say is it's kind of like desktop publication, desktop fabrication. You now can make whatever you want without permission.
Okay.
So some people want to print guns, but some people want to print toys. Some people want to print these new custom designs for their hot rod.
So in theory, I could print a transformer that I've designed myself and,
Yeah, and there's...
part by part, I guess.
Yeah, and
Yeah.
it could be, your own custom transformer with
Wow.
your face on it. So right now there's people trying to figure out what is going to be, quote unquote, the spreadsheet of 3D printing. What's going to be that big kind of driving thing? And
The killer app.
the killer app, exactly.
Right, for 3D
Which I
printing.
don't think we're there yet. We're still in the early stages, comparing back to desktop publishing, where we have low resolution. We're being able to print with one material at a time,
Right.
and that was actually some of the motivation behind what I'm doing. But slowly, you could imagine as you can print more materials at the same time, lower resolutions. You're going,
Yeah.
and as the costs come down, you're going to be able to make a lot of these objects at a much cheaper and easier process than actually going and purchasing it somewhere else.
Interesting. I'm thinking when you go into like a comic store or something and they have, a Batman bust or something and they're selling it for $150 because it's a collector's item or whatever. And if I could 3D print that exact same thing for the equivalent of $50 or something, then, that's...
It might be worth your time, and it might be fun for you to do that.
Sure,
Similar to someone who likes to sculpt or paint or something like that.
And we talked about making jewelry that would be very very difficult to make through traditional methods. I wonder then when you're talking about art, right? If you can create sculpture that would be difficult or nearly impossible to make through traditional sculpting methods, but now you can do it through 3D printing, right? Very
And there
designs.
are a lot of examples out there, and there are
Sure.
these kind of cellular designs that have a lot of really cool stuff on the inside, which cannot really be made, if you're sculpting or injecting or these other manufacturing techniques. But with 3D printing, because you're going up layer by layer, you can control the inside at each step,
Sure.
which is really cool.
That's amazing. That's
You
very
can
cool.
actually control the densities and stuff of the inside as well to make something stronger or heavier or lighter or cheaper,
Okay.
things like that. So you can actually in the software tune all of these little parameters of your final design as well.
Wow. That's, I can't quite wrap my brain around the potential of it, but I think, like you said, this is something that's still kind of in the early stages,
Yeah.
so this is where the experimenting is
So
happening.
the huge uses right now are rapid prototyping for hardware companies.
Sure.
So down at the Communitech hub, I see all of these different companies using 3D printing, Medela Health, Palette, Volterra. They all have 3D printers because they're building their product, and they can come up with a design in the morning,
Yep.
print the next iteration in the afternoon, do all their design critiquing, and the next morning work on
Start again.
iteration number 2. So that's a huge advantage. They don't have to wait a week to send it away, have it tooled, have it come back, or actually machined at a machine shop.
And
They
pay
can-
huge money for that process. as
Exactly.
well,
They
right?
can just hit go
Yep.
and be able to pick it up in a couple hours.
Wow, that's amazing. Well, listen, let's get a little more personal here
Sure.
with you. So maybe you can just share a little bit of your story about how you ended up in the 3D printing world and
Sure.
what was kind of the genesis of structured printing and all that kind of stuff. You've already mentioned that you're finished school.
Okay,
Or
so
just
yeah, that's
about?
where I'll jump in and
Yeah, sure.
kind of start. I'm the structured printing put my PhD on part-time. So I'm technically still in school.
Okay.
But most of my time right now is being focused on the startup. My supervisor at the University of Waterloo is super supportive, and he's actually one of our first customers of our product.
Oh, that's awesome.
So going back to my graduate school experience, I got into materials science in chemical engineering. I did my undergraduate in nanotechnology engineering, so I had this huge drive to design and fabricate different materials.
Sure.
That's always kind of been my push. So through my master's degree, I worked on a technique called electrospinning,
Okay.
which creates these small, tiny fibers by applying this huge voltage, 30,000 kilovolts between two metal plates.
All right.
And you coat one of those plates with a polymer solution, and it will draw them to the other plate and
Okay.
create these nanofibers. So that
Wow.
was really cool. Not really a lot of application.
Well, I was going to say it sounds very kind of sci-fi-ish, but what do you do with it?
Yeah, so it makes this cotton material that
Yeah.
has a surface area that's 1,000 times more than cotton or something. So it has
Okay.
applications in wound dressings or for catalysts, something that could take advantage of this high surface area.
Sure.
But the problem is it's an expensive technique. It's not scalable.
Right.
But then for my PhD, or during my master's and moving into my PhD, I personally started building one of these RepRap or open source 3D printers on my own in my basement.
Yeah.
And my supervisor came across this one day and said, "Bring that in the lab. This is cool." He's a plastics expert. And then he saw that people are now building things with plastic in their houses. This kind of blew his mind. So
Yeah. And did you just decide kind of on a whim one day, yeah, I think I'll build a printer in my basement? Like,
yeah,
okay.
yeah, that's exactly what it was.
Interesting. All right.
It was through my like I said earlier, it was my I wanted to learn a little bit more about robotics and electronics. So it was my
getting your feet
perfect
wet.
excuse to get into that,
Yeah.
and it had a lot of relation to what my career or area of expertise was, being the plastics.
Sure.
So,
Okay. So you brought it into the lab?
Got
yeah?
into the lab, started designing new plastic filaments for 3D printing. So things that are all natural, biodegradable.
When you say filaments, now are you talking about the material being printed?
The feedstock for a 3D printer, a
Right.
traditional 3D printer right now. So just to back up, how a 3D printer works, I was trying to get to this earlier.
Yeah.
I got through all the software stuff, but when it's actually being printed,
Yeah.
it works just like a glue gun.
Okay.
Just imagine it really, really tiny.
Right.
And the glue stick being like a long fishing line.
Okay.
So it builds up this one layer at a time by heating up this tiny little filament of plastic.
Okay.
So that's what I meant by filament.
Okay. Well, and I saw when I was at the Kitchener Public Library looking at their MakerBot there, it looks like a spool.
Yeah, it comes on a big roll.
with a plastic. I don't know what you would call it, like not thread. You
They
would
call it the filament.
Oh, but filament. There you go. That's where the filament comes in.
Yeah,
but,
exactly.
But for someone who has never seen this before, yeah, it looks like a spool of kind of plastic thread that gets fed into the back of the
About
machine.
the thickness of a piece of spaghetti.
Yeah, that's right. Kind of a thick piece of spaghetti.
So I
made
was
of plastic.
designing that
Yeah.
spaghetti using
Okay.
new materials that, and we're still working on it. But at the same time, I thought, why does it have to be a filament?
Right.
Why can't I just print this goo I have over here, this gray goo?
Right.
I can't roll it up into a tiny little line and push it through this machine, but I know I could build it up in this kind of additive process.
Sure.
So at that point, I was kind of exploring ways to do this, playing with some ideas, modifying my MakerBot, hacking, and kind of this maker spirit. It's kind of like hardware hacker. So I was trying to make this system that would 3D print pastes and gels.
Okay.
I didn't get very far with it.
Okay.
But luckily, at the same time, I was attending the Quartz Lab, which is the Kitchener-Waterloo hacker makerspace.
Okay.
And they had started a 3D printers users group. So I had been playing with this idea, and I went to the first meeting and ended up meeting my co-founder, Charles Meyer, there.
Oh, okay.
So this was our first date, if you want to call it.
Sure. And was he already doing some experimentation
So he,
too?
at the exact same time, was trying to solve the exact same problem.
Oh,
So,
Wow.
It's a match made in heaven.
yeah. So we got to talking, and over the course of a couple of months, we decided, okay, you've got a lot of you've got a working product. I've got a lot of the printer integration knowledge.
Yeah.
Let's work together and try to see if other people want to solve this problem other than just us.
Sure.
That was kind of our first step.
Sure.
So we went to the Startup Services group at the Communitech Hub.
Yeah.
They helped us get through a lot of the early stages.
Registering a company.
Registering a
and all that stuff?
company,
Yeah.
setting up a bank account, running some market surveys,
Sure.
polling people, getting feedback, forcing feedback, and
Yep.
and seeing what people say about your product or your idea.
Right.
So it was nice. We had a working prototype, and we actually had some really cool samples that we made.
Right.
So without showing off the guts of our idea, we were able to show these really cool prints and say, hey, this is icing sugar. And
Yeah.
people who have been 3D printing with plastics were just blown away
Right.
by putting this in their hand and said, how did you do this?
Because people had never been traditionally printing with icing sugar or with other kind of
They're limited
gel
to
materials.
two plastics only.
Right. Sure.
So where was I? Okay, so we're at the hackerspace. We kind of
Yeah.
moved into the Communitech Hub.
Right.
Our early mentor was Duncan McDowell, who's now with Blitzen. And one of our meetings, he said, hey, did you guys apply to the Communitech HyperDrive accelerator? And
Yeah.
Charles and I looked at each other and said, hadn't really thought about it, but, why should we? And he said, well, it wouldn't hurt. Like, look through the rules and everything, and we checked it out and ended up applying for HyperDrive.
Okay.
Went through our series of interviews,
Yeah.
Charles and I actually was gone on a nice vacation to Costa Rica during the final interview.
Oh, boy.
So sent Charles in on his own, and he killed it.
Wow.
Actually ended up when he went back to the cafeteria for lunch with his tray of 3D printed icing sugar, had all of the investors and everyone come and see and actually have lunch with him. So
Wow.
that was a cool sign.
That's amazing. Yeah.
So we ended up being chosen as one of the 5 companies in this cohort of HyperDrive.
Wow.
And since then, it's just kind of exploded.
Now, let me just ask a couple of questions then.
Sure.
I think you have a third person as well, right? That's part of your team
Yes.
now?
So we just brought in at the beginning of beginning of May.
Okay.
Time flies. John Mardlin, who
Okay.
is our business development officer
Okay.
with Structured Printing.
Okay. Fair enough.
So being the 2 very technical PhD types, we needed somebody to kind of broaden or round out our team
Sure.
on
sure.
that side.
And how did you end up getting in touch with him? Just through the local circles here in town, or?
Yeah, actually. So this was a tough process for Charles and I finding a third person. We knew we needed a third person.
Yeah.
And we met with a lot of people, but we knew and we had been advised by a lot of people, take your time.
Right.
Like, as much as you need someone now, finding the right person a little bit later is totally worth it.
Sure.
So we met with quite a few people, and all very awesome people, but didn't quite hit that startup, we need you to do everything kind of
Attitude.
skill set, attitude.
Sure. Okay.
And then we were recommended John from one of the startup services team members at the Communitech Hub.
Yeah.
And I was looking through his resume, and I had realized I had already met him through some tech meetups around the city of Waterloo. So
Sure.
I knew this guy. I had actually purchased some product from one of his startups he was running.
Oh.
So that right there was a good strong pull that, I bought something from this guy, so
Sure.
I'm sure other people would.
It's nice to have that pre-established relationship
Exactly.
a little bit, right?
Yeah. It's just enough to give that break the ice kind of.
Sure.
So we met with him over a series of interviews, a couple weeks, and decided, okay, let's make the jump. And
Wow.
looking back, I don't think we could have found a better person. So
Wow.
we're
That's awesome.
we're lucky in that sense. I've heard some horror stories about early startup teams.
Bad matchups, yeah. Now, my other question is this. So when you get into the HyperDrive program, and I've met I've met a bunch of people that have kind of been through HyperDrive or in at HyperDrive now. Do you, what do they give you? They give you office space? Do they give you money? Do they invest in your company? What are kind of the perks of being a part of the program?
Yep. So the big one they advertise when you apply is they'll give you $40,000 for some percentage of equity of your company, typically around 6-7% range. So
okay.
Right off the bat, that gives you a pretty good valuation as kind of a starting point.
Sure.
I believe it works out to about $550,000, which gives a lot of confidence to the company and people looking from the outside to the company. So that's, one of the nice things.
Is that something that's guaranteed once you're accepted into the program?
Yeah, that's guaranteed.
Wow, that's very cool. And can you turn it down if you don't want to give away any equity or take the money?
I think there's some negotiation room around that number.
Okay, fair enough.
So that's kind of the set point, and then you can meet and arrange your own contract. But you're guaranteed at least $40,000 for that percent, which is awesome. Yeah, and you get a workspace. Right. So we're the cohort 4 of HyperDrive, and they totally just did a rehaul of how it kind of works. Right. Typically, it's been a 3-month program. Yeah. They've shifted that now to 3 months with 10 companies. They've shifted that now to 6 months with 5 companies, so they can put a little bit more effort in, and we get a little bit more time. Right. So I'm not sure about the software kind of design cycle, but I think it's around 3 months. It's been successful for things like Y Combinator and a lot of other accelerators, but for hardware, 6 months for us is more than, or not more than, but
it's a better fit.
It's a better fit for sure.
Wow.
And then having office space. So we moved out of Charles' basement, which was a little 4x4 cubby we had with the printer set up on his tool set. Right. To now, the first actually 2 months we were put in a small little office, and we've since expanded, and they've created a hardware room for startups at HyperDrive and Velocity at the University of Waterloo. Right. And we have tons of space now, which is awesome. Wow. And to facilitate all the tools, 3D printers, we have a little bit more than just a laptop to be able to, or that we need to work with. So so having all that space has been awesome.
And nice to have other people kind of working in similar fields nearby that you can interact with. And
everybody's going through the same problems either 3 weeks ago or in 3 weeks. So there's always somebody that you can chat with, which is awesome. It does get a little bit distracting at times, but the trade-offs have definitely been for the good. Right.
That's the major concern of any startup, especially, very early, is, I need a place to work and I need some cash. Yeah. And so it's great that you guys can kind of be handed that. Now, having said that, so you started in HyperDrive a month or 2 ago, 3 months ago? How long has it been?
We started March 7th. Okay. So just past the 3 month.
Okay, so you're a little bit further than halfway, and then you have a Kickstarter campaign as well, right? It's still ongoing.
Yes, so we so we kind of timed this to kind of be right in the middle of our HyperDrive cycle. Sure. We set it up with a goal of $30,000, right? And a time period of 5 weeks, which is 35 days. Yeah. We're about 15 days in, I believe, today. Yeah. And we've raised $94,000.
Wow.
So
that's amazing.
We've tripled our goal. Wow. Which is going to allow us to do 3 iterations of our product, 3 batches is kind of how we set it up to do. So doing hardware, software, you can almost do continuous improvement and push it. But hardware, it's a little different. You have to do it for the next guy kind of. So we've made it pretty clear that we like some early adopters. You get it first, but you get the early version. Right. But your feedback is awesome and very, very much going to help us push it out for iteration 2 and so on. And so 3, it's given us this development cycle. Yeah. And each one is only 100 devices or 100 units. So it's going to be exciting for a team of 3 to kind of put this out.
And it's nice kind of validation, right, from the public and from the market out there that people actually want what you're making and are willing to put their money on the line for it, not just click like on Facebook or something, right?
Yeah, it gives. So for startups, you're looking for product validation and money. And
yes.
Kickstarter gives you both.
Sure.
Which is awesome.
Sure. And we'll, if anybody listening is interested in checking out that page, we'll put a link to their Kickstarter campaign on our website as well, so that'll make it easy for you guys to find it. But so you're 15 days in, there's still 20 days left in that campaign then, I guess?
Yep, 20 days left.
If people still want to donate.
We just got our T-shirt designs today.
Oh, that's
they
nice.
They look pretty cool. We had enough support early on with T-shirts that we hired a designer to put together a really cool logo, so that'll be coming out soon.
Okay.
So if you guys want to help us out and buy a T-shirt, I'll love you forever.
The same one as on the Kickstarter campaign? You show that, it's
no, it's going to be better.
Oh, it's new.
It's got a cool
different.
new design. We're going to be releasing it early next week.
Cool.
I'm assuming you didn't 3D print the T-shirts. We're not quite at that stage yet.
No.
Huh? I'm just kidding.
No.
So, and just to be clear, the product that you're selling, when you're selling a product, it's an add-on device for existing 3D printers. You're not selling a completely separate 3D printer.
Yeah.
Am I
guess
right?
I didn't finish that off from before.
Yeah,
but
sorry.
The product is an add-on that will allow to printing with pastes. So along those ideas I said earlier with printing icing sugar, we can also print with hardware store silicones and latex and polyurethanes, which gives some really good flexible and stretchable properties, which for prototyping has huge applications.
Sure. And there's a cost benefit, I think, as well, right? To be able to print with this number of materials rather than being restricted to the filaments that are typically used, right?
On many different levels, but just by volume, a kilogram of the plastic is about $50. A kilogram of silicone is about $5.
Right.
A kilogram of sugar is even less.
Right.
So in that sense, it's much cheaper. It's a lot more fun materials, in my opinion. Like these new properties you can get. Edibleness, if that's a word.
Edibility, maybe. I don't know.
The stretchability, the flexibility. These are all things that plastic hasn't been able to do. These traditional ABS plastics that have been 3D printed.
Right.
So this has opened the doors to so many new applications, so many new materials.
Yeah.
All at a much lower cost. So there's a lot of huge advantages to that.
Sure. Now, just to let you know, we only have a few more minutes here till we should wrap up. Sure. But maybe you can just let us know kind of what's the future here of 3D, of structured printing. You guys are going to finish out your HyperDrive thing, and then what happens from there? Are you opening an office somewhere?
Did you not learn anything? Accelerator.
Can you say finish the accelerator? Your stint in HyperDrive will be finished.
Our run. No, yeah. So one of the awesome things is it's a 6-month that they give us the office, but they continue their support for 2 years after that. So we get to meet with these mentors. That was the third thing I didn't get to mention, but the biggest thing that HyperDrive has helped us out with, looking back, has been the mentorship. We've been connected with awesome people in manufacturing, awesome people in marketing, and just awesome people in the entrepreneurship startup scene. So that has been great.
Wow.
So moving forward after HyperDrive, we plan to fulfill all our orders from this Kickstarter, so that's going to take a little bit of time.
Sure.
We graduate on September 18th.
Okay.
They're having a nice showcase where the community is invited to come and check out a lot of the companies that were in this cohort.
Cool.
And then after that, we'll be trying to develop some ideas we have is actually providing specialty cartridges of paste for the printers, trying to move from this maker audience who we've been targeting now and make it more of a simple consumer product, like the just press print kind of idea.
Sure.
So trying to, I was discussing earlier, get over that barrier to entry and make it a little more user-friendly so we can push this idea into more households.
Sure. Or even, bakeries who want to, print special designs with their icing sugar and so on and so forth.
Yeah,
right?
Everybody can be like Dairy Queen now and have custom cakes.
That would be amazing. Very cool. Yeah. Well, I wish we had more time to talk, Andrew. Maybe at some point down the road when more things have developed, then we can get an update and see where things are going with you guys. Because, it sounds exciting. 3D printing is already getting so much hype, but with you guys kind of taking it to a whole other level and opening the options for materials in such a huge way, I think, the future potential seems huge, right? So
I'm excited.
Yeah,
Yeah, now that the cost is
awesome.
coming down, sounds a little more accessible. I'd
Yeah.
like to look into it a little more further. So yeah, it's interesting. I don't know what I'd print, but
Print something you can eat. I think that
3D
there's nothing
Yoda
wrong
head.
with printing something you can eat.
Be lots of toys.
yeah.
For sure.
Yeah, lots of Yoda heads.
Yeah. What do
Well-
you have? What have you printed? What's your 3D
Well, I have about 7 Yoda heads
7 Yoda heads?
in
nice.
different materials and colors.
Yeah.
That's like the classic.
That's your go-to.
Yeah, I was going to
print?
say printing a Yoda head is like writing the Hello World
Yeah,
thing
so what-
in software. Maybe,
It's the comparison. It's the check out my Yoda. It came from this printer.
Right.
It shows off the capabilities a lot. So that's why people like to show off their Yodas.
That's awesome.
The coolest thing I've printed. We've printed some custom orthotics. That was pretty awesome.
Oh wow.
neat.
Like so, I could measure my own foot.
Yeah.
Okay, it's this far from the heel to the arch. My arch is this high.
Yeah.
Type it into this Thingiverse profile, so I didn't have to do any of the coding.
Yeah.
Just type in the measurements. It output the 3D file, and I was able to print it in silicone,
Wow.
slide it in my shoe.
That's amazing. That is incredible. You could open maybe a whole new market for people who do a lot of work on their feet and want to make their custom orthotics cheaply, right?
And for
Yeah.
kids who are growing every couple months,
Yeah. 20%
it almost
equity.
justifies.
I want the 20%
cost of a
equity
print.
when you start that business, man. No, I'm just kidding. All right. Well, let's wrap things up here. So first of all, thank you very much, Andrew, for being with us. Andrew Finkle. I'll say your full name in case anybody
Thank
wants
you.
to look you up. We'll include links to Andrew's Kickstarter, and you guys have a homepage as well.
Structur3D.io, and again, the E is a 3.
Okay, there we go. And maybe we'll put his Twitter handle up there too
that
if
one's
you
too
want to follow
complicated to
him.
read.
Yeah, but you can find it on our website. We want to thank the Center for Entrepreneurship, as we always do, for letting us record in their space here. We also want to invite you, please, to send your comments, your questions, your criticisms, and feedback to us. If you want to contact us by email, it's feedback@tspweekly.com. That's Tech Startup Podcast Weekly, but tspweekly.com is what you type in. You can also follow us on Twitter at TSP Weekly. And check out our website, tspweekly.com. You'll find links to all of the articles that we discussed on the podcast, as well as the things that we discussed with Structured Printing and with Andrew. So for myself, Darren Conley, and my co-host, I almost called you the co-horse, I think, by mistake there. My co-host, Stephen Campbell, and from our guest, Andrew Finkle from Structur3D Printing. Thank you so much for joining us today, and we'll see you next week.